student does an investigation to determine the relative formula mass, MR, of an unknown solid diprotic acid, and they've given us a balanced equation. So we've got the acid here that we're trying to find the MR of, and sodium hydroxide. And they've told us that they've prepared 250 centimetres cubed of the acid using 1,300 milligrams, and they've then pipetted 25 centimetres cubed of a certain concentration of sodium hydroxide into a conical flask, and they've titrated it with the acid, which means that these volumes are of the acid. So the first thing we're going to need to do is, using the practical, find the mean titer. Now my hint is always go to the last one, because you continue titrating until you reach concordant results. So we're looking for the titer that is closest to that 26.50 and is concordant with it, so within 0.1. So we find that it would be 26.40, and if you have always gone to the last one, you're just looking for the one closest, and you would always titrate till you reach concordant results, so it should be the last one. So that's our average titer, which is a volume of the acid. So now we can work out the moles of the NaOH in our conical flask. So let's just envisage this a little bit. So in this conical flask, we've put 25 centimetres cubed of 0.112 mole per decimetre cubed NaOH, which was our alkali, and our ratio is 2:1. And above it we've got a burette, and we now know that we use 26.45 centimetres cubed of H2A, but that H2A came out of a volumetric flask that had 250 centimetres cubed and 1,300 milligrams. So let's start off by working how many moles are in the conical flask. If we type that into our calculator, we'll see that we get 2.8 times 10 to the minus 3 moles of sodium hydroxide. So 25 times 10 to the minus 3 times 0.112, 2.8. Now to get from the sodium hydroxide to the acid, what we need to be aware of is that we're going to need to use the ratio, and the ratio from sodium hydroxide, if we go to the balanced equation, so from NaOH to H2A is 2:1. So the number of moles of H2A in the burette, used from the burette, is going to be 2.8 times 10 to the minus 3 divide by 2. So take your answer on your calculator, divide by 2. 1.4 times 10 to the minus 3. Now that's the number of moles in 26.45. So how much H2A was in the big flask, in the 250? Well, we need to scale up 250 over 26.45. How many 26.45s are there in 250? So we're going to get times 250 over 26.45. We're going to get 0.0132. And then we're going to do mass is Mr. Mole, so MR is mass over moles. And our mass was in milligrams. If we type that on our calculator, we get 98.2 as our MR of A. The uncertainty in the pipette. Now you only use a pipette up to the line, so remember the pipette is kind of like this and has one line on it, so you only make one reading, so 0.06, and the pipette measured 25. So what is that as a percentage? That is 0.24%. So very accurate. Before adding the solution from the burette in the rough, there was an air bubble below the tap. So you remember that you have kind of the jet space at the bottom and the tap. So there was an air bubble in this part here below the tap. At the end, the air bubble was not there. Explain why the air bubble increases the final burette reading of the rough titration. So when you open that tap and the liquid above the air bubble drops, the air bubble will come out of the jet and be replaced by the acid. And so that air will have been counted as volume in your final reading. So not only will you have the volume of acid that was used to carry out the titration, but you'll also add on to that the volume of the air. And so your reading is going to be larger. So the air bubble takes up some space. When tap opens, solution, in this case acid, replaces the air bubble. And so that's why our volume goes up. During the titration, the student washed the inside of the conical flask with water. Why does this not give an inaccurate result? Well, adding water to that conical flask does not change the number of moles of alkali, in this case alkali, in the conical. And so it doesn't affect your answer.